Good morning, my dear students. Welcome back to our physics class. Okay, so in the last class we have discussed about universal gravitational law, and we have derived the universal gravitational law. Universal gravitational law, and then we found some constant that is known as what? Universal gravitational constant G, right? Okay, so there are some of importance of the universal gravitational law or the universal law of gravitation. Okay, so that is listed in your textbooks. What are they? The universal law of gravitation successfully explained several phenomena which are believed to be unconnected. Okay, so what are they? The force that binds us to Earth. Okay, so we have already discussed how we can walk through or how the Earth attracting all the objects towards itself, right? That is because of gravitational force, right? Okay, so it can be explained by universal law of gravitation. So the motion of moon around the sun and the motion of planets around the sun and the tides due to the moon and the sun. So these are the some of the phenomena that can be explained by the help of universal law of gravitation. Okay, so you just go through that, and now we can go to another topic, that is free fall. That is, it is related to gravitation. Oh, okay. So now we are going to discuss free fall. So what do you mean by free fall? How we can say one object is freely falling? What is the reason of this free falling of something? That means when an apple falls down to the earth, what is the motion? Yeah, definitely it is because of gravitational force, right? So we can go through the textbook. Let us try to understand the meaning of free fall by performing this activity. So one activity is given to you, activity 10.2. Take a stone, throw it upwards, and it reaches a certain height and then it starts falling down. So we can see, or it is well known to us, that is when we throw something that is like this chalk piece. When I throw that chalk piece, it reaches some height and then it falls down by its own, right? So we have learned that Earth attracts objects towards it, and this is due to gravitational force. Okay, so Earth attracts all the objects towards itself, right? So whenever an object falls towards the earth under this force alone, we say that the objects are in free fall. So that means when I throw this chalk piece upward, then it reaches some height and after it falls down by itself. That means only the force that acting on that chalk piece is, only the force that acting on it is gravitational force. No other force acting on this chalk piece to fall down, right? Okay, so gravitational force മാത്രമാണ് ഈ ഒരു chalk piece അല്ലെങ്കിൽ any object that we thrown upwards. There is no other force acting on that object to pull this towards the earth, right? Okay, so is there any velocity change happen in that object? So we know the freely falling body. That means when an object thrown upward and then it comes down only due to the action of gravitational force, right? So when it falls down, is it have any velocity change? Definitely it will have a velocity change, but no direction change happen. That means freely falling body falls like this, right? So there is no change in direction. Okay, it falls down like a straight line motion, right? Okay, so even though it has no directional change, but the velocity is changing, right? Okay, so we can say the body has some acceleration. When the velocity changes, then what happens? It would have acceleration, right? Okay, so while falling, there is no change in the direction of motion of the object, but due to the Earth's attraction, there will be a change in the magnitude of velocity, right? So the Earth attracts the body or the object, then it has some velocity change, right? That is due to this gravitational force, right? Okay, and any change in velocity involves acceleration. And whenever an object falls towards the earth, an acceleration is involved. That means there is a change in velocity and it causes an acceleration to that body. Okay, so this acceleration is known as what? The acceleration due to gravity. Okay, that is acceleration due to gravity. Okay, and it is denoted by the letter small letter g. Okay, it is denoted by small letter g, which is known as acceleration due to gravity. So this acceleration is due to Earth's gravitational force. Therefore, this acceleration is called the acceleration due to gravitational force of the Earth, or acceleration due to gravity. So you should underline this paragraph. That is from where? Yeah, whenever the object falls towards the earth, an acceleration is involved, and this acceleration due to the earth's gravitational force. Therefore, this acceleration is called the acceleration due to gravitational force of the earth, or acceleration due to gravity. Okay, so you should underline that paragraph. Okay, so it is denoted by letter G, and this have a unit of acceleration itself. So this is an acceleration, right? So what is the unit of acceleration? This is the acceleration due to gravity is also acceleration. The unit of acceleration we know, meter per second square, right? So G is also having a unit of meter per second square. Okay, so the unit of G is same as that of acceleration, that is meter per second square. And we know from second law of motion, that means Newton's second law. What is Newton's second law? From the second law we derive the equation for motion, right? That is F is equal to ma, right? We know F is equal to ma, and it is derived by the help of Newton's second law, right? So we know from the second law of motion that force is the product of mass and acceleration. Okay, so let the mass of the stone, that in the activity 10.2 we thrown a stone upward, right? So the mass of, suppose the mass of that stone is m, right? That is small m. Okay, this is the mass of that stone, and we already know that there is an acceleration involved in falling object due to gravitational force, and it is g, right? So we can write the force is equal to m into g. Instead of this acceleration, we replace for a freely falling body, the body having a mass m and it having an acceleration, that is acceleration due to gravity. So we can write F is equal to mg. Okay, is it clear? So F is equal to mg, and therefore the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to gravitational force, that is F is equal to mg. So here we have the force. This is what force? Gravitational force, right? So it is equal to mass into acceleration due to gravity. Okay, and we know from the law of the universal law of gravitation, we have F is equal to what? The equation F is equal to, what is the equation given by law of universal law of gravitation? F is equal to G m divided by d square, right? So this is universal gravitational constant, and this is the mass of one object, and then the mass of another. That means if it is the mass of Earth, and this is the mass of object, and this is the distance between object and Earth center, right? So when we fall, when we throw a stone, then the stone has a mass of m kilogram, suppose, and here this m is the mass of Earth, right? And this is the distance between the object and the center of Earth. Suppose the object is, now the stone is, this is our Earth, and it has some distance at the Earth center, that is the radius of Earth, right? And suppose the stone is on the surface or near the surface of Earth, right? So we can say the distance between this object, this is the object, or this is the stone having a mass m, right? Suppose the stone is falling towards the Earth and it reaches near or on or near the surface of Earth, right? So we can say that the distance between this object and the Earth center is almost equal to the radius of Earth, right? Okay, so we can replace this F is the gravitational force, right? So we can replace this F by this mg, right? So from these two equations, we can equate these equations, that is mg equal to what? G into m is the mass of Earth, right? M is the mass of Earth, and when comparing to the mass of Earth, the mass of this stone is too small, right? We can say it is negligible, right? While comparing with the mass of the Earth, a stone's mass is too much small, right? So we can neglect that mass. Okay. And what is the distance square? It is almost equal to, if the mass of the stone is near or on the surface, then we can replace this d by the radius of Earth, right? So we can replace this with r square. Okay, so this is what? This is gravitational force, and it is equal to G into m by r square. And from here we can get the value of G. Okay, so what is the value of G from that equation? So we have mg is equal to G m by r square, or we can write this as d square. If the stone is somewhat here, then it will have some other distance, right? That is this r plus some height h, right? So this is the distance. So we can write this as same d, right? The distance between the object and the Earth center. We can write it as d square itself, right? If we take the object is on or near the surface, then only we can replace that d square by r. Okay, ആ ഒബ്ജക്റ്റ് സർഫസിലാണെങ്കിൽ മാത്രമേ നമുക്ക് ഈ ഡിസ്റ്റൻസ് റേഡിയസ് ഓഫ് ദ എർത്ത് ആയിട്ട് എടുക്കാൻ പറ്റുള്ളൂ. ഇഫ് ഇറ്റ് ഈസ് സംവെയർ എൽസ്, സം ഹൈറ്റ്, ഈ ഒരു ഹൈറ്റിലാണ് ആ ഒബ്ജക്റ്റ് നിൽക്കുന്നതെന്ന് വെച്ചെങ്കിൽ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും? സപ്പോസ് നമ്മളൊരു ബിൽഡിങ്ങിൻ്റെ മുകളിൽ നിന്നുകൊണ്ടാണ് ഈ ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ് മെഷർ ചെയ്യുന്നതെന്നുണ്ടെങ്കിൽ, ദാറ്റ് ഹൈറ്റ് ഓഫ് ദാറ്റ് ബിൽഡിംഗ് ഈസ് ടേക്കൺ ടു ബി ദ ഡിസ്റ്റൻസ്. That means this is some height, and from here to here, the Earth center. So this will have another value, that is r plus h, right? So we can write that as d. Our distance നമുക്ക് d ആയിട്ട് തന്നെ വെക്കാം, right? So if we taking the object is on or near the surface of the Earth, then only we can take the radius. Okay, d നമുക്ക് radius of the Earth വെച്ചിട്ട് replace ചെയ്യാൻ കഴിയും. Okay, so from here g is equal to what? Here, if we take this, here we neglect the mass of that object, right? So if the mass of this object is here, then we can cut this mass, and this is also the mass of that object, right? Okay, so these will cancel each other. How it will cancel each other? When we take this into this side, what will be happen? This mg divided by m, right? So these two will cancel. സോ ഇക്വേഷൻ്റെ രണ്ട് സൈഡിലും മൾട്ടിപ്ലൈ ചെയ്തിട്ടാണ് ഒരു കോൺസ്റ്റന്റ് ഉള്ളതെന്നുണ്ടെങ്കിൽ ദാറ്റ് വി ക്യാൻ അവോയ്ഡ് ദാറ്റ്, റൈറ്റ്? അത് രണ്ടും ക്യാൻസൽ ചെയ്ത് പോകും. സോ ഫ്രം ഹിയർ വി ഗെറ്റ് g ഈസ് ഈക്വൽ ടു gm by r square or d square. Okay, so the value of g we get gm by r square. Okay, so it is given in your textbooks, that is from equation, that is the equation of law of universal gravitational law of universal gravitational law, and the force, that is gravitational force, is equal to mg. When comparing these two equations, we will get mg is equal to gmm by d square. Okay, that is, here we replace the d square with r square. Okay, so d square, if it is d square, we can write this as d square. Okay, d square എന്ന് വെച്ചിട്ട് തന്നെയാണ് നമ്മൾ കൊടുക്കുന്നതെന്ന് വെച്ചെങ്കിൽ mg is equal to gmm divided by d square എന്ന് വരും. And from that we get g is equal to gm by d square. Okay, so this is the equation for what is g? Acceleration due to gravity. Okay, it is the universal gravitational constant into mass of earth divided by distance between the square of the distance between the object and the earth. Okay, so we get g is equal to gm by d square. So where the mass m is the mass of the earth and d is the distance between the object and the earth, and let an object on or near the surface of the earth, then the distance d will be equal to r. That means the radius of earth, right? If we take that d as r, then we will get this, g is equal to gm by r square. Okay, and that is given to you equation 10.9, g is equal to gm by r square. The earth is not a perfect sphere, right? It is somewhat an elliptical shape. We know that earth is somewhat sphere, but it is not an actual sphere, right? So as the radius of the earth increases from the poles to the equator, so it is not a perfect sphere, so that the radius have some change. The radius is increasing from poles to the equator. Okay, so poles in equator like വരുന്നതോറും ഈ radius increase ചെയ്തുകൊണ്ടിരിക്കും. ഇക്വേറ്ററിലായിരിക്കും ഏറ്റവും ഹയസ്റ്റ് റേഡിയസ് കാണിക്കുക, റൈറ്റ്? Okay, so the value of g become greater at poles than the equator. So r is greater means the value of r increases means the value of g decreases, right? So because r is in the denominator. Okay, so r is in the denominator of this equation, that is gm by r square. When r increases, then g decreases. Then r decreases means g increases. That is, the value of g become greater at the poles. That means the radius of earth is low when compared to equator and pole. That means the radius of earth is less for poles than compared to equator. So equator സംബന്ധിച്ച് ഇക്വേറ്റർ റീജിയനിൽ നോക്കുമ്പോൾ റേഡിയസ് എന്തായിരിക്കും? കൂടുതലായിരിക്കും. റേഡിയസ് കൂടുതൽ മീൻസ് at that places g is less, right? Okay, so the value of g become greater at the poles than the equator. For most equations, we can take g to be more or less constant on or near the earth. So for some calculation and to do some problems and related things, we take g as constant, right? But one thing you should know, that the g is varying from equator to poles, right? But for practical applications, we take g as more or less constant. Okay, so but for objects far from the earth, the acceleration due to gravitational force of the earth is given by the equation, this equation, G is equal to Gm by d square. Okay, so earth in the near or the on the surface, when the object is near or on the surface of the earth, then only we can apply this equation, right? Object എർത്തിനോട് വളരെ അടുത്ത് അല്ലെങ്കിൽ എർത്ത് സർഫസിലായിരിക്കുമ്പോഴേ നമുക്ക് ഈ ഇക്വേഷൻ യൂസ് ചെയ്യാൻ പറ്റുള്ളൂ. ആൻഡ് ഇഫ് the object is far from the earth, then we have to take this equation, that is G is equal to Gm by d square. എർത്തിൽ നിന്ന് ഒരുപാട് അകലെയുള്ള ഒബ്ജക്ട്സിന്റെ മേലുള്ള ഗ്രാവിറ്റേഷണൽ ആക്സലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി കാണണമെന്നുണ്ടെങ്കിൽ we have to apply this equation. Okay, so now we are going to calculate the value of G. Okay, so how we can calculate the value of G? So equation for G, we have G is equal to Gm by d square, and if the object is on or near the surface, then we have G is equal to Gm by r square. Okay, so from these equations we can calculate the value of G. Okay, so we know we are taking the G as a constant for practical applications, right? So that constant value we have to calculate, right? So we can apply the values of all these terms and then we get the value of G. Okay, so now we can calculate the value of G. Okay, so we have the equation G is equal to Gm by d square, or G is equal to Gm by r square. Okay, so when the body or when the object is on or near the earth, this value we are going to calculate. Okay, so to calculate the value of G, we should put the values of universal gravitational constant G. That means this value and the mass of the earth and the radius of the earth. So we have G is equal to, that is capital G is equal to, what is the value of gravitational constant? 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Okay, so 6.7 into 10 raised to minus 11 Newton meter square per kilogram square, right? And what is the mass of earth? Mass of earth is given as 6 into 10 raised to 24 kilogram. Okay, 6 into 10 raised to 24 kilogram. And what is the radius of earth? The radius of earth is also given as 6.4 into 10 raised to 6 meters. Okay, 6.4 into 10 raised to 6 meters. Okay, so put all these values into this equation. So we will get G is equal to G into M divided by R square. 6.4 into 10 raised to 6 the whole square. Okay, so we only need the value of G, right? So these are complications. You don't bother about all these complicated mathematics. You should know what is the value of G. So it is given in your textbooks. While doing this, when we do all these calculations, we will get G is equal to 9.8 meter per second square, right? That is G is equal to acceleration due to gravity. So we should give the unit of acceleration. So G is equal to 9.8 meter per second square. So this value you should keep in mind. Okay, so G is equal to 9.8 meter per second square. This is the value of acceleration due to gravity. Okay, so we get the value of acceleration due to gravity of the earth. That means the earth attracts all body towards itself, that is by the force, gravitational force, right? So that acceleration of the object that is falling towards the earth is having a value 9.8 meter per second square. Okay, and now we are going to find motion of objects under the influence of gravitational force of the earth. So we know the earth attracts all the objects towards itself, right? So we are going to discuss the motion of objects towards or motion of object under the influence of gravitational force. Okay, so gravitational force in naturally എങ്ങനെയാണ് ഒബ്ജക്ട്സിന്റെ മോഷൻ എന്നുള്ളതാണ് നമ്മൾ ഇനി നോക്കാൻ പോകുന്നത്, right? And let us do an activity to understand whether all the objects hollow or solid, big or small, and will fall from the height at the same rate. So we are going to discuss, or we are going to find whether all the objects, that means higher objects, that means having high mass and less mass, all the objects, right? All the different objects is falling towards the earth at the same rate or different. That all things we are going to find. Okay, so the activity given to you, take a sheet of paper and a stone and drop them simultaneously from a first floor of a building and observe whether both of them reach the ground simultaneously. So we have to take a sheet of paper and a stone. So which will come first? What is your opinion? Which will come first? Yeah, it is, we know the stone will come first, right? But it is due to what? There is an air friction, right? So paper sheet is having some less mass and the air friction acting on it is high, right? So that only because of this air friction, the paper sheet will come a little bit later than that of the stone, right? Okay, so we see that paper reaches the ground little later than the stone. This happens because of air resistance. Okay, so this happened because of air resistance. The air offers a resistance due to friction of motion of the falling objects, and the resistance offered by air to the paper is more than the resistance offered to the stone. And if we do not if we do the experiment in a glass jar from which air has been sucked out, the paper and the stone would fall at the same rate. So if we suck all the air, that if we do this activity, that means throwing a paper sheet and a stone simultaneously into a jar, that is, the jar is vacuum, that means the air is sucked out. എയർ എല്ലാം സക്ക് ചെയ്ത് കളഞ്ഞിട്ടുള്ള ഒരു വാക്വം ട്യൂബിൻ്റെ ഒരു വാക്വം ജാറിനുള്ളിലാണ് നമ്മൾ ഈ എക്സ്പെരിമെൻറ്റ് കണ്ടക്ട് ചെയ്യുന്നതെന്ന് വെച്ചെങ്കിൽ വി ക്യാൻ ഫൈൻഡ് ദാറ്റ് ദ സ്റ്റോൺ ആൻഡ് ദ പേപ്പർ ഷീറ്റ് വിൽ കംസ് ഡൗൺ simultaneously, right? Both will reach the earth or reach the surface of that bottle at the same time, right? That means that there is no air friction acting on the objects. The only force that acting on that objects is the gravitational force, right? So when both the objects act under the influence of gravitational force, they have an acceleration due to gravity. G is equal to 9.8. So this is common to both that paper sheet and the stone, right? So they will reach at the same rate. Okay, so we know that the object experiences acceleration during free fall, and this acceleration experienced by an object is independent of its mass, right? So this G is constant for any objects, right? It is not depending on the mass of the object. That is, here we can find that is G is equal to Gm by r square. So here only the terms that is G depending upon the gravitational constant and the mass of earth and the radius of earth, right? That means G have no dependence on the mass of the object. Objectന്റെ മാസുമായിട്ട് G dependent അല്ല. That is, G is independent of the mass of the object, right? That is why we know paper sheet has less mass when compared to stone, right? But if there is no air, then what happens? Both them falls at same rate. Okay, that is G is independent of mass of the object. And this means that all the objects, hollow or solid, big or small, should fall at the same rate. According to there is some story behind this, and Galileo dropped different objects from the top of the Leaning Tower, Pisa, in Italy, to prove the same. So Galileo did all these experiments what they did in ancient days, right? Okay, so all these experiments are done by so many scientists, and they conclude after all these experiments, they conclude that gravitational acceleration due to gravity is same for all objects, right? Okay, so as G is constant near the Earth, all the equations for uniformly accelerated motion of objects becomes valid with acceleration A replaced by G. Okay, so we know this in the case the G having value Gm by r square. It is in the case of the objects are on or near Earth, right? So on or near the if the object is on or near the Earth, all the equations of motion, we have 3 equations of motion, right? That we have already studied. So what are the equations of motion? That is, first one, V is equal to U plus AT, right? Velocity and acceleration related equation, V is equal to U plus AT. And what is the second one? Second one, S is equal to UT plus half AT square, right? So this is the second equation of motion. And what is the third one? 2as equal to v square minus u square, or we can write v square is equal to u square plus, or we can write this as the same, v square minus u square is equal to 2as. Okay, or we can write v square is equal to u square plus 2as. Okay, so all these equations are valid when we apply the acceleration due to gravity. Okay, so as G is constant near the Earth, all the equations for the uniformly accelerated motion of objects become valid with acceleration A is replaced by the acceleration due to gravity. So we can write this V as V is equal to U plus, instead of A, we can replace A with G. That is, V is equal to U plus GT. Right? All other terms, that is V is equal to final velocity and U is equal to initial velocity, T is time taken. Okay, all other the other have the same definition. Okay, and only the acceleration is replaced by acceleration due to gravity, and S is equal to what? UT plus half GT square. Okay, and V square is equal to U square plus 2GS. Okay, so all these equations are valid. Okay, so that is where U and V are the initial and final velocities, and S is the distance covered in time t. Okay, so in applying these equations, we will take acceleration A to be positive when it is in the direction of velocity, and that is in the direction of motion, and the acceleration A will be taken as negative when it is opposes the motion, right? So here we take the value of G as positive. G is positive if it is in the direction of motion. That means when a body is freely falling, the body has a motion towards the earth, right? So we can take the G as positive. That means acceleration and the motion are same direction. But if we throw a stone upward, what happens? The stone has a tendency to come down, right? But we thrown that upward, right? At that time, we take the g as negative, right? That means the acceleration due to gravity is against the motion of that object, right? At that time, we take g as negative. Okay, so that is given. That is in the if the acceleration due to gravity is in the direction of motion, then we take that as positive, and it is taken as negative when it opposes the motion, right? When it opposes the motion means acceleration is against, if the acceleration is against the direction of motion, then we take that as negative. Okay. So here is an example given to you. Example 10.2. A car falls off ledge and drops to a ground in 0.5 second, and let g is equal to 10 meter per second square. So for simplicity, for doing problems, we take most of the case we take g is equal to 10, that is 9.8. 9.8 we can approximate to 10 meter per second square, right? Okay, so if it is given in your question, then only you can take g is equal to 10. Otherwise, you have to take g is equal to 9.8. Okay, question 10 ആണെന്ന് തന്നിട്ടുണ്ടെങ്കിൽ നമുക്ക് g is equal to 10 എന്നെടുക്കാം. Otherwise, you have a value 9.8. Okay, so what is the question? What is its speed on striking the ground, and what is its speed on striking the ground? What is the average speed during the 0.5 second? 0.5 second the average speed and how high is the ledge from the ground? Okay, so ledge means nira tattu ennokke parayum nammal, right? So some height from that of ground il ninnu korchu height ilulla oru place. Okay, so what happens? A car falls off a ledge and drops to a ground in 0.5 second. Okay, so time is given and also g is given, right? Okay, that is t is equal to 0.5 seconds and what g is equal to 10 meter per second square. And what we have to find? First question, we have to find what is its speed on striking the ground. So we have to find v. That means velocity. Speed means it is magnitude. The magnitude is equal to its velocity, right? Okay. So we have to find v, and we know u is equal to 0. Initial velocity will be 0, and we have the equation v is equal to u plus gt. So we can apply v is equal to u we have 0 plus g we have 10 into t we have 0.5, right? So we will get v is equal to what? 10 into 0.5. 0.5 means half, right? So it is 5 meter per second. Okay, so we get v is equal to 5 meter per second. And then second question, what is its average speed during the 0.5 second? So average speed, we have to find the average speed, so that we have to find what? V plus u by 2, the initial velocity and final velocity. The average speed means initial velocity plus final velocity divided by 2, right? So now we have v is equal to 5 and u is equal to 0. So what will be the average speed? Average velocity or average speed, we can write it as average v. So what is v plus u by 2? Okay, that means 5 plus 0 by 2 is equal to what? 2.5 meter per second, right? So the average speed, we get this as 2.5 meter per second. So what is the next question? How high is the ledge from the ground? So how high means the distance between that ledge and the floor or the ground, right? So the distance, we can find the distance by using s is equal to ut plus half at square, or we can use this v square is equal to u square plus 2as. From here also we can find s. Okay, so we can directly use this equation. S is equal to ut plus half at square. U we have 0 into time 0.5 seconds plus half into g we have 10 and t square is equal to 0.5 into 0.5. Right? Okay. So now we will get this will become 0. 0 into 0.5 will become 0 and half into 10 become 5 and 0.5 into 0.5 will get 0.25. Right? Okay. So the value will be equal to what? We can write this as 0 plus half into 10 into 0.25, right? So this will equal to 5 into 0.25. 5 into 0.25 is equal to 1.25 meters. Is the distance having a unit of meter. Okay. So we get the distance also 1.25. Okay, so that is given. That is the question. So first one, what is the speed on striking the ground? That is, we get v is equal to 5 meter per second. Okay, so its speed on striking the ground is 5 meter per second, and the average speed during 0.5 second is 2.5 meter per second, and the height of the ledge from the ground is 1.25 meters. Okay. So next an example is given to you, that is also solved, and you should write it in your notebook. And also you should write the questions. One, what do you mean by free fall, and what do you mean by acceleration due to gravity? That are questions you should write on your notebook. Okay. So you should do all these things, that is as homework. Okay. So we can meet in the next class. Hope you all clear all the things that we have discussed today. Okay. So if you have any doubt, you can ask me anytime. Okay, through WhatsApp. So we will meet in the next class with some other topics. Okay. So we can meet in the next class, students. Thank you.